Good morning, this is your Stat Sensei, Mr. Spensei, and this is a paired t-test, and we're actually going to run a paired t-test. The previous video was an interval on getting the lead out. This is a long scenario. Let's get reading. Lead found in some paints is a neurotoxin that can be especially harmful to the developing brain and nervous system of children. Children frequently put their hands in their mouth after touching painted surfaces, and this is the most common type of exposure to lead. In Flint, Michigan, many have alleged that the amount of lead exposure is significantly higher outside. That's going to be a key word, outside than inside, and have recommended that daycare centers no longer allow children to play outside due to the amount of exposure to lead. So, in other words, they're saying it's so bad outside that kids should not go outside because they could get lead poisoning. And they said outside is greater than inside. That's important information that we're going to need for this hypothesis test. The city of Flint, Michigan has commissioned a study to explore this claim and randomly selected 9 children. So our sample size is 9 from over 35,000 in the urban daycare centers. So they're telling us right here that this is our population. All right. And it was nice to let us know that they were randomly selected. That's probably important. To conduct the study, the hands of the children were wiped clean. They were then allowed to play outside for 1 hour, after which the amount of lead in micrograms on each child's dominant hand was recorded. So they measured whether, hey, if they're right-handed, they measured it on the right hand. If they're left-handed, they measured it on the left hand, just because that's what we tend to touch with. Um, the child's hands were cleaned again, and then were permitted to play indoors for an hour. After the 1 hour of indoor play time ended, the amount of lead on each hand, dominant hand, was measured again. So, in other words, the dominant hand was measured once outdoors and once indoor. Because we were measured twice, remember, to be paired, something has to be measured twice. Okay. The distribution of the differences is normal. All right, they told us it was normal, which is good because our sample size is too small to use central limit theorem, all right, because our sample size is 9, all right? The information on outside versus inside is shown in the table below. So I've already input that data into my table. And in case you've missed it, I need the differences. Because it's paired, they were tested twice. I need to get those differences. To do that, blue button 1 minus blue button 2. And there, that populates the differences. Now my sample size is still 9. It's these highlighted data points. Yes, I know I had all this information. I have 18 data points that are measured, but all we care about are the differences. All right? So the question, using the data from the scenario, determine whether or not the amount of lead on the dominant hand is greater after having played outdoors. So they're looking for outside being greater than inside. Outside amount of lead being greater than inside. Well, our formula is the same formula that we've continued to use for t distribution, because the t distribution was exactly the same thing except without the d's. All right. Then when we're running a paired, the assumption is that there is no difference. So while this seems weird, paired will start off having a mean of 0. So the population claim mean is 0, and that will always be the case. Well, I input all that data and I have it in L3. So I'm going to do a stat calc, 1var stat, blue button 3. And I end up getting a sample mean of 3, which I also recorded here, and the sample deviation of 4.854. So I have that information written down. And please don't forget, N is the number of pairs. All right. In this case, we have 9 kids, and they are measured twice. They were measured on their dominant hand outside and measured for lead on the dominant hand inside. We're running a 1-sample paired t-test. All right. So remember, when we're doing a hypothesis test, Confidence interval, they're always centered on X bar, but hypothesis test, our drawings will always be centered on the population mean. So we're going to be centered on 0 for this, and we have a sample mean of 3, and we were looking for greater than, so that's what we're going to circle, all right? When we plug in, we have our sample mean of 3 minus our population mean of 0 divided by the standard deviation divided by the square root of the sample size, okay? Please note, we thought outside was going to be higher than inside, so that means 20 greater than 10. That just gives us something to practice with. So the null hypothesis, very simple. It's just this every single time for paired. So mu equals 0. Done. Simple. Well, the alternative is going to start off with mu. It's also have a 0, but we're going to be looking for a greater than, as we have up here. Please make sure that you include the D's. Without the D's, this is not correct. So you need to have these D's right here. So our parameter, let mu D, notice this is a change. Instead of just being mu, it's let mu D equal the true population mean, and you have to add this phrase of the differences. Why? Because up here, we took all these differences. So we're taking the average of the differences, mean of the differences in the amount of lead. And then you also have to add one more thing. Which way did you subtract? Because you technically could have done inside minus outside, but we did outside minus inside. You need to give that answer because that's going to switch the direction of all your work. All right. Super important that you say what it was. So we said outside was greater than inside. If you had done inside first, this would have swapped directions. Everything would have changed. So make sure that you always define that. Random sample of our first condition, random sample of 9. And I'd like you to go ahead and add the word pairs because we have 9 pairs. And that was given to us. Okay. The next one, we need to check that the differences are independent. They are. And then the last thing we need to do is we need to go 9 times 10 is 90, and that's less than 35,000. This is just going to be an always. You can just write it down. And then finally, our sample size was not large enough to be normal by central limit theorem, so we can't use that. Differences are normal, and this was given. And one other thing I should have said, 9 times 10, we are always multiplying by 10, gives us the 90. That's less than our population size of 35,000. They gave us way up here. So N is less than 10% of the population. All right. Let's go ahead and run this test. Stat test, t-test. We have data. Our mean is 0. Our data list is now 3, blue 3. And we said greater than, so we need to make sure that we have a greater than symbol selected. And we calculate. When we get T star is T is 1.85409 and a p-value of 0.0504. So our alpha level is 0.10, 0.054 is less than 0.10, so we reject the null. Our p-value is 0.0504, which is less than our alpha 0.1. We reject the null. There's sufficient of evidence to suggest the true population mean of the differences. Let's talk all about this real quickly. I'm going too fast. So our p-value is 0.0504, which is less than our alpha. That came from right here. P-value is 0.0504, which is less than our alpha of 0.10. The next thing, we reject a null. That came from right there. And then we say there's sufficient or enough evidence to suggest that the true population mean of the differences, let's star that, the true population mean of the differences in the amount of lead outside minus inside. That's exactly what we had up here. And please make sure you have to have mean of the differences, and you have to say outside minus inside, is greater than 0 mcg. And where that came from, greater than 0, greater than 0. And really, we should have probably labeled these as mcg and mcg. All right? So that's the way it all lays out. I sure hope this helped, and I certainly look forward to seeing you on the next one. Thank you.